Math 12A. I want to go over, I'm not going to do the homework per se, but I want to talk a little bit about what they were looking for, or what I was looking for in a few of those questions, because some people did some stuff that you didn't need to do, but you didn't do some stuff that you did need to do when I looked at your homework. You said I proved it because, but that didn't necessarily prove what they asked you to prove. So I'm going to talk about that just a little bit, and then I'm going to finish off this section. There's not a lot more to it. There's just 2 more examples and actually only 1 more formula, so they're quick. So yesterday, was it yesterday? Yeah, I think so. Yesterday when we talked about the slope of a line and the length of a line, and those were really the only 2 formulas that we talked about using. So I want to look at 7, 10, and 11 because those ones to me seem to be the problems for most people. So in number 7, it said the vertices of a quadrilateral are, and it gives you the 4, and it says verify that it's a rectangle. So I want to talk about what you should have done to verify that something is a rectangle. So here's what I want you to think about. With a rectangle, what do you know about a rectangle? You've known for a long time some things about rectangles. For instance, you know that this side should be the same length as this side, and you know that this side should be the same length as this side. So one of the pieces to proving that it's a rectangle could be finding the length of the line. But here's the problem. That doesn't necessarily prove it's a rectangle, because a parallelogram, which is curved like this, would also have this line the same length as this one, and this line the same length as that one, but that's not a rectangle. That's a parallelogram. So length of the line could be helpful in proving it's a rectangle, but it doesn't definitively say that's a rectangle. Another thing you could say is that this line and this line have to be parallel. And I had said in the video yesterday that parallel lines have the same slope. So if I find the slope of this line and I find the slope of this line and they're equal, then have I not proven that it's a rectangle? Well, again, let's think about it. In a parallelogram, this line and this line would be parallel, and this line and this line would be parallel. So again, I haven't distinguished that it's a rectangle versus a parallelogram. So what is different about a parallelogram versus a rectangle? The thing that's different is all of the corners make right angles. They are perpendicular. This line, there was a fly that just pinged my whiteboard. This line is perpendicular to this line. In other words, they are at 90 degrees to one another. What do I know about perpendicular lines? I know that the slopes are negative reciprocals of one another. If this slope was 1, this slope would be -1. If this slope was 1/2, this slope would be -2/1. So what I would do is I would find the slope of this line, and rather than finding the slope over here, I would find the slope of this line and show that they are perpendicular to one another. That would be the fastest way to prove that it's a rectangle, with me doing the least amount of work. So you really have to think about, what are they asking me for? What am I trying to prove? And how do I prove that? So again, I'm not going to sit and do the math on that because the slope formula is right there. And what I saw was not really mistakes in the math so much as mistakes in what you chose to do to prove something. Number 10 said verify that the quadrilateral with these specific vertices this time is a parallelogram. So we want to prove that it's a parallelogram. So same thought process. What would prove to me that it's a parallelogram? I don't actually have to prove that it's a rectangle. It might be, but they don't care. They only care that you prove it's a parallelogram. The word is right in there, parallel. The opposite lines should be parallel. So if I find the slope of this and the slope of this side, they should be the same. If I find the slope of this side and the slope of this side, they should be the same. That would prove it's a parallelogram. So would the lengths of the sides, because the length of this side and the length of this side should be equal, and the length of this side and the length of that side should be equal. Because a rectangle is a type of parallelogram. It's just that a parallelogram is not necessarily a rectangle. So you have a little bit more leeway in question 10 as to what do I do to prove that it's a parallelogram. I could find the lengths of the sides and show that this side and this side are the same length and this side and this side are the same length. Or I could have found the slopes and proved that this slope and this slope are the same and that slope are the same. So I actually had some choice on that. Number 11 said this time you have a triangle, and again it gives you the vertices, and it says show that it's an equilateral triangle. So really all of the side lengths should end up being equal. If they didn't, that means that you just made a calculation error somewhere. You just screwed up where you put an X, where you put a Y, that kind of thing. Don't worry too much about that. But if that's what you did, you found the lengths of the line, all three sides should be equal. All right, so that's how you would do 7, 10, and 11. And again, as I looked through them, I'm not necessarily, when I check your homework, it's just like I check your homework at school. I'm looking for doneness, and I'm glancing through to see that your answers make sense. I'm not looking through every single little step of everything that you do, because the answers are at the back of the book for the most part, not really for the prove ones, but so I really am relying on you to be figuring out, do I understand this, do I not? And if you don't, for you to be asking questions. You really need to be doing that. That's important. All right, so we're going to finish up this section today, and we're going to talk about one more piece of information that can be useful, and that is something called a midpoint. A midpoint is just where is the middle of a line. Where is the middle? If you're going to cut the line in half, where would that be? Now, I want to point out that the word is midpoint. Whenever you're giving a point in graphing, that means there has to be an X and there has to be a Y. So with a midpoint, you shouldn't end up with an answer of 7. That doesn't make any sense. It's a midpoint. There should be an X value and a Y value, 7 and -3, something like that. All right, it's a midpoint. And the formula for that, for the X value, you take your X1 and your X2, add them together and divide by 2. And to figure out the Y value, you add the two Y's together and divide by 2. You're really just finding the average or the middle. All right, so we're going to do example 2 and example 3. Won't take long. It's pretty quick. It says verify that the diagonals of a parallelogram with vertices -2 and 1. So again, I'm going to draw this because it helps me. -2 and 1. That's W. Takes me longer to draw it than do the question. X is 3 and 3. 1, 2, 3, 1, 2, 3. That's X. Y is 4 and -1. 1, 2, 3, 4, and -1. And Z is -1 and -3. So if I join this, I have a parallelogram. Kind of looks like a rectangle. And it says verify that the diagonals. So if I draw, let me do this in a different color. So if I draw a diagonal line from one corner to the other, and I draw a diagonal line from this corner to the other, it says verify that the two diagonals bisect each other. That word bisect means they cross each other in exactly the middle. So if this is a parallelogram, this diagonal line and this diagonal line would be the same length, and so their middle would be at the same point. So what I'm actually looking for is I'm looking to see what is the midpoint between W and Y, and what is the midpoint between X and Z. And if, in fact, those two diagonal lines bisect each other, the midpoints will be the same. So, midpoint is for W and Y, from W to Y. So, I take my X values, -2 and 4, and I add them together, and I divide by 2. And I take my Y values, 1 and -1, and I divide them by 2. So what does that give me? -2 plus 4 is 2, divided by 2 is 1, and 1 plus -1 is 0, divided by 2 is 0. So it says the point should be 1 and 0, and by graphing it, I kind of know whether that makes sense or not, because it does look like they kind of cross over 1 and at 0. It's so far this seems to make sense. So X to Z, again, I'm going to find the midpoint, so I'm going to take the X values, 3 and -1, and I'm going to add them together and divide by 2, and I'm going to take my Y values, 3 plus -3, and I'm going to divide them by 2. So that's going to give me 3 plus -1 is 2, divided by 2 is 1, and 3 plus -3 is 0, divided by 2 is 0. So my midpoints worked out to be the same, so I've just proven that they bisect each other. Ta-da! That's example number 2. Example number 3. Example number 3 says something or other. All right. I'm going to erase these formulas because I'm going to need more space. Keep them in your head on a sheet of paper somewhere. Okay. I just stepped on a fly. Okay, I'm having fly issues today. This is the weirdest video. The vertices of a triangle are -3 and 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. That's A. I hope that's as far back as it goes. -3 and 6, 1 and -6. 1 and 1, 2, 3, 4, 5, 6. And C is 5 and 2. 1, 2, 3, 4, 5, 1, 2. Why did I have to make it so big? Okay. So I have this triangle, something like that. So what does it want me to do? So in part A, it says if M is the midpoint of AB. So A to B, M is the midpoint. So I'm going to say the middle looks to me to be somewhere here. So we're going to call that M. That's the midpoint. And N is the midpoint of AC. A to C. I'm going to say the middle's right about here. We're going to call that N. Now, right about here doesn't really work for math. So the first thing I'm going to do, I haven't even seen what it's asking me to do yet. Doesn't matter. The first thing I'm going to do is I'm going to figure out where exactly is M, where exactly is N. So for point M, I'm going to find the midpoint between here and here. So for point M, I'm going to do x plus x, so -3 plus 1 divided by 2. And I'm going to do y plus y, so 6 plus -6 divided by 2. So negative 3 plus 1 is negative 2, divided by 2 is negative 1, and 6 plus negative 6 is 0, divided by 2 is 0. So negative 1 and 0. So that kind of makes sense. I just was off a little bit on where my middle was. It was just up here a little bit. So that's fine. So negative 1 and 0. And n, same thing. I'm going to take my x's, negative 3 and 5. I'm going to add them together and divide by 2. And the y's, 6 plus 2. And I'm going to divide by 2. So negative 3 plus 5 is 2, divided by 2 is 1. And 6 plus 2 is 8, divided by 2 is 4. So over 1 and up 4. That kind of makes sense. 1 and 4. I might be off a little bit in my picture, but I'm not too bad. So 1 and 4. All right, so I still haven't done whatever it is. It says verify that the line from M to N. So if I draw a line from M to N, they want me to prove that that is parallel to BC. They want me to prove that from B to C and from N to N are parallel. Parallel lines have the same slope. So I'm going to find the slope from M to N, and I'm going to find the slope from A to C, because they want me to prove that BC, they want me to prove that MN and BC are parallel. That would mean they have the same slope. So slope is y2 minus y1 over x2 minus x1. So for MN, that's red. For MN, y2 minus y1, so 4 minus 0, and 1 minus negative 1 for my x's. Whoops, 1 minus negative 1. So that's 4 divided by 2, which is 2. So my slope for this line is 2. Now what about BC? BC is y2 minus y2 minus y1. So 2 minus negative 6 over x2 minus x1. So 5 minus 1. So 2 minus negative 6, that's 8. And 5 minus 1 is 4. So that's 8 over 4, which is 2. So my slopes are the same. So I've just proven that those two lines are parallel. But it didn't just ask that. I only read the first half of this sentence. The other half said, so it said verify that the lines are parallel and prove, show, verify that that MN is half the length of BC. Because this is in the middle, this line should be half as long as this line, which means I have to find the length of those lines. So I have to find the length of MN, and I have to find the length of BC. BC is obviously the longer one. It's going to be 2 times bigger than this one, or this one's going to be half what this one is, whichever way you want to look at it. So the formula is the square root of x2 minus x1 squared. So x2 minus x1, so let's say that's 1 minus negative 1 squared. You can even just take it from here if you want. Plus y2 minus y1, so plus 4 minus 0 squared. So that's 2 squared, which is 4, and that's 4 squared, which is 16. And so that is the square root of 20. Again, you don't even need to solve it. You don't need to simplify it. You just leave it as root 20 because you're just hoping that the other side will be half that length. If you want to, you can make it a decimal if that makes more sense in your head to turn it into a decimal. Or you can simplify it. It would be 2 root 5 because this is 4 times 5. The square root of 4 is 2. Or if you like decimals better, that's all good. Root 20 is 4.47. So for lack of a better, 4.5, okay? So any of those will work. Length of BC. BC is x2 minus x1 squared plus y2 minus y1 squared. So again, 5 minus 1 squared plus 2 minus negative 6 squared. And again, like this is y2 minus y1, this is x2 minus x1, so you can just take those if you want. 5 minus 1 squared plus 2 minus negative 6 squared. So 5 minus 1 is 4, squared is 16, and 2 plus 6 is 8, squared is 64. So this is the square root of 80. The square root of 80 actually breaks down to 4 root 5, which is 2 times bigger. Or if you, again, if you like it better as a decimal, square root of 80 is 8.9, which is close enough to 9. So 4.5 and 9. One is 2 times bigger than the other. All right. Let me see. So there is a part B to that, but we're not going to do the part B because it's a lot more generic. It doesn't give like actual points. We're not doing that. Example 4, we're also skipping. So that's all we're doing. I will again put up a few more questions for you to try, and we'll talk to you again tomorrow. For you, this is Wednesday. It always blows my mind. I don't know how like TV hosts do it, because they record it 3 days in advance, and so they're always saying it's Wednesday, but for them it's like Saturday or something. I can't do it. So for me right now it's Tuesday, but you will watch this on Wednesday. All right. Talk to you again soon, I guess. Bye.